Find the gain of the circuit shown below. So if I am indicating this as VA, from the virtually short circuit concept, this node having the potential VI, so if we apply the KCL at VA as well as node VI, we will get as VA minus VI by 1, VA by 2, VA minus V0 by 2 is equals to 0. That is equation 1. If we apply the KCL at node VI, that is VI by 1, VI minus V0 by 1 is equals to 0. From this equation we will get VA as 2VI. This is equation 2. So solve the equation 1. VA minus VI, VA plus VA minus V0 is equals to 0. So V0 is equals to 4VA minus 2VI. VA is nothing but 2VI from the equation 2. So this is V0 is equals to 8VI minus 2VI, which is equals to 6VI. Hence gain is V0 by VI, that is A is equals to 6. That is option B is correct. The inverse jet transform of a given expression, that is AZ into Z plus A divided by Z minus A whole cube. Here f of n, suppose an u of n, whose jet transform is f of z is z by z minus a. If we find d square f of z, we will get this as 2a z minus a whole cube n square f of n is equals to n square an u of n, which is equals to, if we apply the z transform to this equation, we will get z d by dz f of z plus z square dz square f of z. Z d by dz f of z is equals to minus az z minus a whole square. So by substituting these two values into this equation, we will get n square a power n u of n is equals to az z plus a divided by z minus a whole cube. Hence option C is correct. The Boolean function f is implemented in the figure using two input multiplexers as shown in the figure. See now, here suppose I am indicating this one with f1. F1 is nothing but b bar c plus b c bar. So f is nothing but f1 bar 0 and f1 a, so which is equals to a into f1, that is b bar c plus bc bar. Hence option A is correct.
20 volts by 440 volts transformer having short circuit impedance of 100 ohms when referred to low voltage side. Okay, he has given jet short circuit for low voltage side as 100 ohms. Now calculate the short circuit impedance when referred to high voltage side. Now what is Z short circuit when referred to high voltage side? Okay, it is given as Z at C low voltage side divided by Okay, which is 220 whole square into, what is the high voltage side voltage? 400 whole square. Or you can write this one as ZSC low voltage side into K square. What is K there? K is equal to 440 by 220, that is transformation ratio, which is equal to 2. Okay, so this is 100 into 4, which is equal to 400 ohms. That is option A is the correct answer.
Boolean function given below, we have to find out the minimal product. That means maximum equation means in terms of SOP, in terms of POS form, product of sums. So in order to find out that thing, we have to use the K map for this one. That is this is WX, YZ, 1, 3, 4, 5, 6, 7, 11, 14, 15, 0, 0, 0, 0, 0, 0. So we have to group this. There are two max terms. This is M1, this is M2. See, M1 can be written as this is 1110, so W bar, this is 0001, so Y, and this one is 0010, this one is X plus Z, that is option C is correct.
50 Hz 6-pole induction motor is filled with unbalanced 3-phase supply. Calculate the relative speed between rotor and rotor backward field. The speed of the rotor is 900 rpm. Okay, he has given speed of the rotor NR is 900 rpm. What about NS? NS is equal to 120 into F by P, which is equal to 120 into frequency is 50 Hz by 6 poles. See, this is 1000 rpm. So slip is equal to 1000 minus 900 by 1000, which is equal to 0.1. Okay, this is a slip, or you can say it as 10%. The supply is unbalanced, so the current in the induction motor is positive sequence as well as negative sequence. Okay, since supply is unbalanced here, it will have positive sequence as well as negative sequence currents. Okay, so there is a backward field. If there is a backward field, now what is the speed? Speed is given as 2 minus S into NS in single phase induction motor. So this is 2 minus 0.1 into 1000. This is equal to 1900 rpm, which is option C is the correct answer.